Welcome. In this video, I'll showcase Unreal Engine's operational lifecycle. Now, one might ask why this is important. It is very useful to know how Unreal Engine creates the systems that we're using to interact and implement our logic. So, understanding how the systems work, in what order, and what actually survives level loads, what actually is being recreated and destroyed, will give you a much better understanding when you're trying to implement logic where you want to add a feature or system, where the system should actually go, under which class. I've been using Unreal Engine since version 4.20 up until the very latest, which currently is 5.7.2 at the time of recording this video. Now, in order to get started, I decided to get a tutorial, maybe tutorial might not be the best word. I decided to start a video series which will showcase Unreal Engine's internals, what's under the hood, and the systems that we're using to create game experiences. These systems work in specific order, and knowing how the systems work will be very useful even if you are using Unreal Engine already. And that's the main reason I decided to start Game Dev Talk, which is a channel that will serve a video series around Unreal Engine, and also I'll be hosting podcasts around game dev as well, thus the name Game Dev Talk. So let's get started with the very first thing which Unreal Engine creates when we fire up, when we start the game. And if we take Unreal Engine specifics out of the equation for a moment, we will see that because every game starts from somewhere, in Unreal Engine, when we start the game, the first thing that we are calling is the game instance. Now, before any level loads, anything at all, before we have anything visually, the game instance, it's the very first class that actually is being called. All right. A few points to clarify about the game instance. It behaves like a singleton, although by design it's not a singleton, which means we can have only one. We cannot have 2, 3, or 4, 5 game instances. And that means that the game instance is the most ideal in order to have, for example, cross-level states, something that will persist throughout many different levels. And it's useful also for adding logic during the whole runtime of the application of the game. So from the moment we press start till the moment we quit the game, and game instance is not being recreated. There's only one, exists globally. And one clarification to point out to fellow developers, game developers, when we are using the editor and we are actually testing multiplayer replication and we are launching 3 or 4 instances in order to check how if replication works and how it behaves. Each instance, each window, it's actually a different game, thus another game instance. So that's the only exception when we are actually using multiple game instances, but still it's the same game instance. All right, if we're running 4 windows, then we're running 4 different games, and this results in 4 game instances. But when a player launches the game, there's only one game instance up until during the entire lifetime runtime duration, and it will only it will survive and it will only close when we are actually quit the game. So I've added some useful information, mainly visually, to as a key takeaway about the each class. So for the game instance, 1 per running game, and it does survive level loads. So after the game instance, what do we have? We have the level load, and the level is being loaded right away, which to put it in a way, to put it exactly as it is, the level is just context. There's no brain, there's no logic. We do have, however, volume triggers in level, but volume triggers are not evaluating any conditions, right? If we have a volume trigger which the player overlaps with, the condition will be evaluated elsewhere in a different class. So the level does not contain any logic. It's only context, geometry, debris, anything that we want to visually represent our world exists on the level, but no logic, no brain, and that's the key takeaway of the level. And context switch, actors, and world triggers. It's the key element, takeaway that we can get. Right after the level load, we have game mode. Okay, the level is loaded and it's looking for a game mode. Now, the game mode is the class where all the win and lose conditions exist. Like everything that the game by design will actually is allowed it to do. All of this should go, and usually that's the case, in the game mode class. Right? The game mode is being recreated per level. That's one very good thing to keep in mind, because even if we are using the same game mode in different levels, it's still being recreated. All right, we can use it in 2, 3, 5, 10 levels, same game mode, same rules, nothing changes, but whenever we're loading up a level, the game mode changes, and that's, one thing to keep in mind. Also, although we will not dive into multiplayer, specifics right now, because the operational lifecycle for multiplayer differs a bit. There's a couple more classes that are being loaded up, such as, game state, for example, a couple of more. But keep in mind, just as a hint, when we will cover the multiplayer specifics in a future video, that game mode exists only on the server. Okay, when it comes on for designing multiplayer games, game mode is only on the server side. All right, and game rules and recreated per level is the takeaway about game mode. Now, right after game mode, right after game mode, we have the player controller, one of the most misunderstood or confused classes. Now, the player controller, in order to provide, some information to try and clarify what a player controller actually does, is mainly and only player intent, okay, and input. So what the player wants to do, input-wise, controls, this is the player controller's role, okay. There's no physical body for the player controller. There's, this player controller is not a character, and that's where most of the confusion usually hangs. Player controller is mainly the class which is represents a player's intent, and it does survive pawn death, like when a character dies and it's being recreated. Player controller is not being recreated, it's there. Now, one point also to clarify and share some information about player controller. This class can possess multiple pawns throughout its life cycle. All right, player controller can possess different pawns. So that's one very good thing to keep in mind as well. And what we have is player input and intent, and that a player controller can possess, different pawns. Okay, so right after the player controller, we have the class which, visually is what we see, and that's the pawn. Pawn and a character, are they any different? Well, not exactly. The character class, it's actually a pawn, which is, which does have additional features, and that's the whole takeaway about what a character is. A pawn is what we see in the world. It's actually the body, and if we put an analogy between player controller and a pawn, we can, describe it as the player controller being the puppeteer and the pawn being the puppet. So the player controller actually controls what the puppet will do, or what the puppet wants, the puppeteer to do. So that's, one good analogy I could think of about player controller and pawn. And a character is nothing more than a specialized pawn. with additional features such as animation support, character movement component, etc. And what we have about the player, the pawn is actually a physical body, what we see in the world, and the character is nothing more than a specialized pawn. So that's the Unreal Engine operational lifecycle when it comes to single player games. For multiplayer, we will cover it in a future video, and we will also start showing in editor and an IDE in order to code some logic and see how this affects what we want to do based on the video, because Unreal Engine is quite big engine with lots of systems. It can be used for a wide variety of purposes, to put it in that way. We will not dive into it, of course. So we will start covering more in-depth knowledge about using different systems throughout, across the engine. But in order to get there, it is much better to actually start from its core, how the engine works when it starts an application, which the classes that are being loaded up first, and like this, it's easier to actually understand also and distinguish if you try to implement something, where that something should go. Okay, if it is something that should persist throughout the entire game, or if it is something that it will be only there only for a session, and it will be destroyed and recreated constantly. So one hint, in a way, something that I wanted to share. So the engine's design here, top to bottom, we see that long-lived. We start from the game instance, which is the long-lived, and we go down to the pawn, which is the short-lived. It's being destroyed and being recreated all over and over again. Because when we play a competitive game, for example, and we're getting killed, and the pawn is being recreated each time that we are getting back to the game. All right. And the final, I think it's like top defines what, and bottom defines where and how. This is one key distinction also to keep in mind. Okay, starting from the game instance, the top, down to the pawn, which is the bottom. So that's it for Unreal Engine's operational lifecycle under a single player game. We will cover multiplayer in a future video, and we will start playing with the editor and an IDE as well for showcasing different systems, all the internals in the engine. We'll try to cover most parts that make more sense, from gameplay ability system to AI behavior, Blackboard design, and behavior trees, and we will start playing with lots of different things, but starting from how the engine works, how the life cycle is. I truly believe it was it is a good starting point, and it's also a good stopping point for this video right now. So I want to thank you for your time listening and watching this video. If you have any comments and feedback, please use the comment section and share your thoughts, opinions, anything that will make game dev talk and what we're trying to do here more useful and better in ways that will also benefit you as well in return. So thank you for your time, and I'll see you in the next video. Bye bye.